Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there is a PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. We have a particle A that is projected at the origin with the angle theta and the velocity of v. At the same time, we have another particle, that is particle B, projected horizontally with initial velocity of u at the height of h. And the position vector of A is given so as the position vectors of particle B. The angle theta is chosen so that tan theta is equal to 2. The two particles collide by first showing that cos theta is equal to 1 over root 5. Verify that v equal square root of 5 times u. So first of all, don't forget angle theta is between 0 and 90 degrees, acute angles if you like. So first of all, we know that tan theta, let me just write that on here. So tan of theta is 2. That means 2 over 1. So of course, we have a right angle triangle here. So this is tan of theta. We have opposite over adjacent, 2 over 1. And we can find the hypotenuse by using Pythagoras theorem. So 2 squared is 4, plus 1 is 5. So that means square root of 5. So cos of theta, is adjacent over root 5. Adjacent over hypotenuse. So there you go. So now we need to show that v is equal to square root 5 times u. So when the particles collide, so this means that the two position vectors are equal. In another word, r of it is equal to r of bt. So that means we can just look at the I component and we put them equal. So let me just write this down. So that is vt cos theta is equal to ut. That is for I component. So there you go. And we know that the t we can cancel out. And that means, so that is v times cos of theta. Cos is adjacent over hypotenuse. So which means 1 over square root of 5 is equal to u. And if I times square root 5 on both sides, so this means that v is square root of 5 u. So there you go. Part 2. Show that the particles collide at time capital T h over 2u. So when they collide at time t is equal to t, so this means that they both have the same coordinate, that is I component and j component. So now we just put the j component, okay, they're equal at t equal capital T. So let me just write this down. So that is vt sine theta, vt, that is capital T of course when they collide, sine theta minus a half g capital T square is equal to, that is for particle A for j component and equal to the j component for particle B. So that is this. So that is h minus a half g capital T square. So keep that in mind because small t equal capital T when they collide. So now I just simplify this. So these two I can cancel out. And now v, don't forget, is equal to square root 5 times u. So just put that in. So square root of 5 u and times t and sine of theta. So sine theta is 2 over square root of 5. So that is 2 over square root of 5 is equal to h. Then we just simplify this. This cancel with this. So that is 2ut is equal to h. So therefore, if I divide by 2u, so that means t equal h over 2u. So there you go. That is the answer. When the particles collide, their velocity vectors are perpendicular. Show that h is equal to 2u squared over g. So because their velocity vectors are perpendicular, that means the velocity vector of A dot the velocity vector B, and then that gives us 0, okay, because they are perpendicular. So we already have these two vectors here. So that is the position vectors. So we just need to find the velocity vectors for vector A and B first. So let me just write this down. R dash IT. So that gives me V cos theta. Don't forget we differentiate respect to t, okay? So for J component, so that becomes V sine theta minus, so the 2 bring down, you cancel with a half, so that means GT. So there you go. And then the velocity for vector B, so that is B T, that will give me differentiate UT, so that give me U, and differentiate H is 0 because it is a constant. We differentiate negative a half GT squared, give me negative GT. So when they collide, that means it's at time is equal to T. Okay, so let me just substitute this in. That means the velocity vector at capital T for A is this. V cos theta. And then V sine theta minus G capital T. And for V, so we go R capital T. For B, that will give me U negative G capital T. And we just find the dot products, equate that equal to 0. So let me just write this down. So R, and we dot R equals 0. So this means that V cos theta, V sine theta minus GT dot U negative GT. So that is equal to 0. So we just need to solve for this. So that becomes UV cos theta. We add negative GT. V sine theta. Don't forget, we just times this with this. Okay. So that is plus. So G squared T squared is equal to 0. So what I do, and we just need to solve this. But then remember V equal 5, square root 5 of U earlier. There you go. V is square root of 5U. So that is U times square root of 5. U and cos of theta is this. 1 over square root 5. So we times 1 over square root of 5. And then we minus GT. V is square root of 5U. And sine of theta, so that means opposite over hypotenuse. So that give me 2 over root 5. So times by 2 over square root of 5. And then we add G squared T squared is equal to 0. So now we just simplify this first. So we know that these two cancel out. So that will give us U squared. And then we have this cancel with this. So that becomes 2 u gt. Okay, so that become minus 2 ug capital T, and then we add g squared times t squared. I can write like this. So g squared t squared, I can just write like this, equal to 0. See, there you go. We just need to solve this quadratic equations. So what we do, if you recognize this is a perfect square. Now, don't forget, we have this perfect square. A squared minus 2ab and plus b squared, that is equal to a minus b all square. Okay, so this is perfect square. So that will give me like this. U square, that means u minus gt, because this is a and this is b. And this is square is equal to 0. To solve for this, so this means that u minus gt is equal to 0. And now we just move this on that side. So that is u is gt. And t must be equal to u over g. So there you go. But then we know that we need to show h is this. And we know that t is h over 2u. So h over 2u. So t is h over 2u. That equal u over g. And if it times 2u on both sides, so this means that h will give me 2u squared over g. So therefore, h is 2u squared over g. Let me check the questions. So there you go. That is the answer. Part 4. Prior to collisions, the trajectory of a particle A was a parabola. Of course, we don't have to prove this. Find the height of the vertex of that parabola above the horizontal plane. Give your answer in terms of height. So this means that we just need to find the maximum height of this parabola in terms of height. And to find the maximum height for this parabola here, that's this particle A. So the vertical component, the velocity, must be equal to 0. And we find t first. So when you get the t, we need to substitute the t into the j component. And so we can find the maximum height. So first of all, we know the velocity of particle A. So this one here. Okay, so that is the velocity of particle A. But then the vertical component, okay, that is the vertical velocity is equal to 0. So we just need to solve for t first. So let me just write this down. So v sine theta minus gt is equal to 0. V sine theta minus gt is 0. But we know that v is square root 5 times u earlier, or square root of 5u. And sine theta is equal to 2 over square root of 5 from this part earlier. So there you go, 2 over root 5. So sine is opposite over hypotenuse. So that means we times by 2 over square root 5 and minus gt is equal to 0. So that cancel with that. So this means I move this on that side. So 2u is equal to gt. Therefore, t must equal to 2u over g. Now that we find time, so we need to find the height, okay, the maximum height. So we need to substitute the time 2u over g into the j component, okay, the position vector. So it will give us the maximum height. So this one here, okay, we need to substitute into the positions vectors. So the j component is vt sine theta minus a half gt squared. Let me just write this down. So that will give us the maximum height. So y is vt sine theta minus a half gt square. Okay, let's say this is yi, because we just need to focus on the y component, because we need to find the maximum height for particle I. Okay, so now t is equal to this. So when t is 2u over g, so yi is equal to v, that's v here, don't forget, is square root 5 times u, or square root 5u. And t is 2u over g. And sine theta is 2 over square root 5. Earlier, let's have a check. So there you go, 2 over square root 5. So 2 over square root 5. And we minus a half. Gt is 2u over g all square, because this is t square. T is this. So now what I do, I just need to simplify this. So we can see this square root 5, we cancel this. And then we have 2 times 2 is 4, and u times u is u square. So that is equal to 4u square over g. And this one here is 2u square, give me 4u square over g square. So minus a half g times 4u square over g square. And these two here cancel with this, give me 2. And this we cancel with that. So left with g underneath. So that is equal to 4u square over g minus, so we have 2u square over g. And we can collect this like term, so same common denominator. So 4 minus 2 is 2. So the answer is 2u square over g. So let's check the questions. So we need to find the maximum height in terms of height, right? So the height is this. So height is 2u square over g. So therefore, we also have 2u square over g. So you got that is equal to height. So therefore, there you go. Thank you so much for watching. Bye.